Hello, this is a presentation of all equipments we are using in AE341 lab sessions at San Diego State University. All the experiments are conducted in the lab AIS 010, which is located at the ground floor in the Engineering Interdisciplinary Sciences building, which is besides the southern face of the Engineering College building. Many signs regarding coving safety cautions are displayed at the entry door. When you enter into the lab, you can see to the left-hand side two sinks for emergency eye wash in case a student has some chemicals in his eyes. Beware, the water is not for drinking. You can see also signs recalling to clean any workspace that the students use. Also, there is a sign to remind keeping social distancing. There is a spray sanitizer and a yellow box which contains a spill kit.
You see here the volumetric bench, which will provide us with the desired water flow. To obtain the reading of how much water volume we dispose, we use the following graduated volume reading gauge, which is in liters. This is the transparent cylinder, which will contain the water generated by the nozzle. This is the nozzle. The water will exit from the orifice and hit the deflector, the flat one or the hemispherical one. As usual, let's have a look on the equipment that we have. So here, like in the first lab session, we have the volumetric bench, which will represent the source of water and where we are going to calculate how much volume do we have in order to get the volumetric flow rate. And this is the H5 Venturi meter apparatus. As you can see, it has an inlet, a conversion portion, a throat, and an outlet. Okay, it has 11 ports connected to water manometers, which are these graduated pipes here. But during the experiment, we will not use all of them. Instead, we are going just to use the first station. Here it's station A. Second station, station D, which represents the throat. And the last station, station L, we are going to call it station 2. So let's get a look. So this is like the picture of how the Venturi tube looks like. So this is station A, B. We have 11 ports corresponding to these 11 water manometers. So we are going to work only using station A, which is we will call station 1, station D, which is the throat, and station L, we are going to call station 2, which is the outlet. So here we are going to use this pipe, and this pipe. Hello and welcome to the third fluid mechanics lab AE341, which is about an experimental study of a jet flow naturally discharged through an orifice. Let's take a look at the equipment. The following apparatus is composed of a transparent reservoir, which has a small orifice here at this bottom, a sliding diffuser, okay, which introduces external flow supply to the reservoir, a pitot tube here to measure the total pressure of discharging jet flow, and a metallic blade here. Okay, this metallic blade is to measure the diameter of the jet stream. To measure the head of water inside the reservoir and the head of water flow acquired by the pitot tube, we use 2 water manometers here with a maximum capacity of 390 millimeters. Hello and welcome to the fourth fluid mechanics lab AE341, which is about studying the flow inside a long and thin pipe. Our objective is to observe the variation of head loss with velocity over a range of Reynolds number, including both laminar and turbulent flows, and to compare the variation of friction factor with Reynolds number with published results. As usual, let's have a look on the equipment. The following apparatus is composed of a long and thin horizontal pipe, which is connected to two kinds of manometers, a water and mercury ones. This is the water manometer, and this is the mercury. You can notice here that it's gray. We will see the utility of using mercury shortly. The following knob allows us to select which manometer we are going to use to get the reading. If the knob is in this position, that means that we are reading the mercury manometer. However, if the knob is vertical like this, it means it's a water manometer reading. This is the regulator that we are going to use to control the flow in the pipe. So, this direction, counterclockwise it opens, clockwise it closes. Unlike the previous labs, the flow will be extremely slow, and thus we are not going to use the whole volumetric bench to calculate the volume and time. Instead, we are going to use the following graduated beakers. We have two kinds here to measure the volume of the fluid flow. Hello and welcome to the fifth Fluid Mechanics Lab A341, which is about studying the discharge of flow over sharp-edged weirs. Our objective is to obtain empirical equations for the flow of water over a rectangular and V-shaped weir, and to compare the resultant discharge coefficients with accepted values. As usual, let's have a look at the equipment. So the following setup is composed of the volumetric bench, where we have a reservoir enclosed by a plate which serves as the role of a weir. So here let's take the rectangular weir and we slide it in this location. Okay, make sure there is no gap. Okay. Also, we have a sliding ruler which has a tip. So this tip to measure the height of the free surface of the reservoir upstream, where the velocity is negligible in comparison with that at the crest of the weir. Hello and welcome to the sixth and also the last fluid mechanics lab for AE341, which is about studying the flow inside the network of pipes connected with different types of fittings. The objectives of this lab are to determine the loss coefficients of various fittings in pipe flow and to compare these values with accepted ones. As usual, let's have a look at the equipment first. The following setup is composed from the volumetric bench and a network of pipes which has 5 types of fittings. So the first type is this 90 degrees sharp-edged miter. The second type is this small radius elbow. Third type is this enlargement, so the diameter here increases. Then you have a contraction section, a contraction fitting here. Then we have a large radius band fitting, which is this one. To look up at the dimensions of pipes and fittings, we can check the following diagram. So we can see it here. So this is like the following diagram. It shows you the outlet control valve, the pipes, the different fittings and the diameter, the angles and the radius, different kinds of radius. So as for example, the diameter of a smaller bore pipe is 28 to 5.5 millimeter. The diameter of a larger bore pipe is 29.6 millimeter. The radius to center line of elbow is 14 millimeter, and the radius to center line of band, which is 45 millimeter.